Okay, so Coulomb's law. Um, what might just look like a spot on the paper is actually a proton. There's an electron. This proton is attracted to the electron. The electron is attracted to the proton because they have opposite charges. Opposites attract. We've seen that, when you were a kid playing with magnets and stuff. And so we know that this is true, is that, there's going to be an attraction between opposite charges, and then there's going to be a repulsion of two negative charges or two positive charges. Since the proton's positive, the electron's negative, they have a attraction for each other, and that's kind of what holds the electrons in the electron cloud. And if they get enough energy, they leave that, but we're not there yet. So rather than just describe it in qualitative terms, we can talk about it quantitatively. So this is the formula. Force, which is a force in newtons, you'll talk more about that when you get to physics class, is defined as this constant. Now you'll notice the constant, all it does is it cancels out the top Coulomb charge here and the bottom radius in meters. So always make sure that your radius is given in meters and your charges are given in coulombs. I don't think there's going to be a lot of situations where you have to change it, but if you do, it'll be more often they'll give it to you in centimeters or micrometers or some other unit, and you have to just switch it to meters, which we can handle. Now, often in chemistry, the Q's are some multiple of 1.60 times 10 to the negative 19. That's the charge on, if it's positive, it's a charge on a proton. If it's negative, it's a charge on an electron. And you would expect those to have the same charge because, they balance each other out in the atom. So you got a constant times the two charges and then divided by the square of the radius. So what I do is I'd multiply across my top and then divide it by the bottom squared. Now, what you have to do is you have to get your calculator correct to make sure when you're doing the division, you're not doing the division and then squaring it. That's going to be a whole different thing. So I figured we could do a problem here. What is the magnitude of attraction between an iron nucleus and its innermost electron? And then they just give us the radius there, and it's convenient because it's in meters. 1 times 10 to the negative 12 meters. So this is easy. It's a plug and chug problem. So I just have to take F equals K Q1 Q2 over R squared. So my K is 8.99 times 10 to the 9th Newton meters squared over Coulomb squared. And then I'm going to multiply that. Now, my positive is going to be times 26 because it's an iron nucleus. That's why they told us it's an iron nucleus. So 26 times 1.60 times 10 to the negative 19th coulombs times negative 1.60 times 10 to the negative 19th coulombs all over 1 times 10 to the negative 12 meters, and that's squared. So this looks like really impressive chemistry here when we put that in, but if we know how to use our calculator, it's not that big a deal. So I'm just going to go real quick here. 8.99 times 10 caret 9, boom, times 26 times 1.60 times 10 caret. I know this is really exciting to watch me plug a calculator on a video. Times negative 1.60 times 10 caret negative 19, boom, boom. So your top, you should get negative 5.98 times 10 to the negative 27. So I'm going to divide that by parenthesis 1 times 10 caret negative 12, boom, square that bad boy, put in my other paren, boom, And so my answer should be negative 5.98 times 10 to the negative third newtons. Right there. And I realize I said caret a bunch of times in that. And when I'm talking about caret, what I'm talking about is that guy right there. And a lot of times you'll see that when I was your age, a lot of times it looked like that. And so my teacher called it a caret, so I just keep calling it a caret. So that's how you do Coulomb's law. I'll probably do another video on that, and you can see that next.